Bismillahirrahmanirrahim. My name is Talha Javed and the topic of my presentation is Scrambling signal encoding technique. So first of all, what is scrambling? Scam- Scrambling is one of the most important technique that is used to convert digital data into digital signals. As we know that most of our computers generally generate digital data and we need to convert these digital data into digital signals. So first definition of scrambling is just the rearrangement of data sequence, and we use scrambling when we have consecutive zeros in our data sequence. So the benefit of scrambling is it prevent unauthorized access of data. If there is if there is consecutive zeros in our data sequence, it is easy to access for other people. So in order to prevent these access, we use scrambling. And the second one advantage of scrambling is time extraction of data. When there is consecutive zeros in our data sequence, the problem of Rx time extraction occur. So as example, if we have a data sequence in with consecutive zeros, and this is the problem. So in order to prevent these consecutive zeros problem, we use scrambling, and by using scrambling we convert this data sequence into 0 1 forms, which in this form signal is easy to extract. Now there are types of scrambling. There are two types of scrambling, by B8ZS and HDB3. B8ZS stands for bipolar 8-0 substitution and HDB3 stands for high density bipolar 3-0 substitution. B8ZS, we use bipolar 8-0 substitution when we have 8 consecutive zeros. Like in this example, we have 8 consecutive zeros. And the point to be noted is that if we have 8 zeros in our sequence, like in this example, we have 8 consecutive zeros, but they are not consecutive, like 1 4 0 1 and again 4 zeros, they are not consecutive. So in this situation we do not use bipolar 8-0 substitution. And the second one example, high density bipolar 3-0 substitution, we use high density bipolar 3-0 substitution when we have 4 consecutive zeros. Like in this example, we have 4 consecutive zeros. In both types of scrambling we use same approach of as from AMI, but the difference is that when we have 8 consecutive zeros we use bipolar 8-0 substitution, and when we have 4 consecutive zeros we use high density bipolar 3-0 substitution. Now discuss these types of scrambling in detail. Here, bipolar 8-0 substitution. The example for there is an example for bipolar 8-0 substitution, and in this example, as we see, we have 8 consecutive zeros, and this is our data sequence, and the output of this data sequence is 1. This one is for first positive half, and the next one we take the inverse of the first positive half is negative half, and these zeros are a straight line. And in this example the problem is the zero constant line. So in order to solve this problem we use bipolar 8-0 substitution technique. In bipolar 8-0 substitution technique we have two patterns. If the last one signal before the consecutive zeros, this one signal is positive, we use this pattern: 000, positive half, negative half, 0, negative half and positive half. And if the last one signal before the consecutive zeros is negative signal, then we use this pattern: 000, negative half, positive half, 0, positive half and negative half. Now solve this example. First, for negative, if the last one signal is negative, first one signal is positive, then take the inverse of the first one signal is negative half, then we use this pattern: triple zero, negative, positive half, 0, positive half, negative half. Then 3 zeros, negative half, positive half, 0, positive half, and negative half. And here you see V. V mean violation of AMI rule. AMI rule says that if the last one signal is negative, then take the inverse of that signal. Like if the last one signal is negative, then the next one signal must be positive. But here we see last one signal is negative, then after 0 the next one signal is also negative, so it is the violation, and we write it as V. And B mean bipolar. It means that if last one signal is negative and next one signal is its inverse, like in this is positive, so we says it as bipolar B. Again here is a violation because last one signal and the next one signal both are same positive, then again a bipolar. The output of this signal is 0 0 0 VB 0 VB. Now we take example for the positive. When the last one signal before the consecutive zeros is positive, we use positive pattern. First one is negative, then take the inverse of this half, positive half, then zeros, positive half, negative half, then again 0, then negative half, and positive half. Here again is a violation because last one signal is positive and this one signal is also positive, and again this is a bipolar, and again is a violation because last one and next one signal both are negative, and again a bipolar. You see, and the output of this signal is 000 VB 0 VB. You see that in both cases, for positive and for negative, the output is same. Now we discuss about high density bipolar 3-0 substitution technique. The example for high density bipolar 3-0 substitution technique is 1 1 4 0 1 and 4 zeros. We use high density bipolar 3-0 substitution because of these 4 zeros. The output of this signal is, first one is for negative half, next one for inverse positive half, then 4 zeros, then negative half, then 4 zeros. The problem in this signal is these consecutive zeros. And remember a point: when we count when we take these 4 zeros, we don't count these ones, we just count this one. And in order to solve the high density bipolar 3-0 substitution problem, we have 4 patterns. Negative mean last one signal before the consecutive zero is negative. Positive mean last one signal before the consecutive zero is positive. And the new thing in the high density bipolar 3-0 substitution is odd and even. Odd and even mean the signal before the number of ones before the consecutive zeros. Like in this we have 2 1, and for these 4s we have 1, we don't count these ones. If the last one signal is negative and the number of 1 is odd, we use the 000 negative half, and if the last one signal is negative and the number of 1 is even numbers, then we use positive 00 and positive. And if the last one signal is positive and the number of 1 is odd, we use 000 positive half. And if the last one signal is positive and the number of 1 before the consecutive zero is even, we use negative half, 00 0 0 and negative half. So here is the solution for the above problem. First one is for negative half, then next one inverse for inverse, and we have 2 1, so, and the last one signal is positive, so we use this case. Last one signal is positive and the number of 1 are even, so we use this pattern: negative 0 0 negative half, negative half, 0 0 and again negative half. And here is a violation because last one signal and next one signal are same, both are negative. And here is the bipolar because last one signal is positive and next one signal is negative. And here is we have 1 and 4 zeros. 1 and 4, last one signal is positive, last one signal is positive, and odd number of ones are odd, we use 0 0 0 positive. 1 number of 1, 0 0 0 and positive half. And this is violation because it is against the AMI rule because both signal are positive. Thank you.